Welcome to my video. My name is Imran Khan and I would like to prove the following statements. Every classification on X generates an equivalence relation, and equivalence classes under a given equivalence relation represent a classification on X in the financial, mathematical and economic context. Basis for the following proof is the well-known formula from the compound interest calculation, this one here. And we consider the set of all pairs of numbers consisting of a real number and an integer. Any payment with a fixed amount k, which takes place at a fixed time t, can be described by the pair of number kt. I will call the element just by the first letter, like k1 or k2. We define a relation on the set as follows. Two elements k1 and kt relate to each other if they correspond to each other according to the compound interest calculation. So the first statement, each class of the given set generates an equivalence relation in the given set. So suppose we have a class of the given set. This is the notation of the class. Then the class division corresponds to the following relation. K1 and K2 relates to each other if they are in the same class. So if K1 and K2 relates to each other, then this means here that the two belong to the same set or class. And this relation is reflexive, symmetric and transitive, and thus an equivalence relation. Why? Because if K1 is in the class, then it is in the class. And if K1 relates to K2, then this means that they are in the same class as said before. And it doesn't matter if K1 relates to K2 or if K2 relates to K1. They are both in the same class. And suppose we have another element that also relates to K2, so K2 relates to K3. So that means that K2 and K3 are in the same class. Then this must mean that K1 and K3 also relates to each other, and thus K1 and K3 are also in the same class. The next statement, equivalence classes under a given equivalence relation represent a classification on the given set. We will prove this by proving A and B. Equivalent elements have the same equivalence class. So if K1 relates to K2, then they have the same class. And we will prove this statement by using both the statement that the equivalence class of K1 is a subset of the equivalence class of K2 and the other way around, so that the equivalence class of K2 is a subset of the equivalence class of K1. So let's start with the statement that the equivalence class of K1 is a subset of the equivalence class of K2. Let's just begin by consider an element that is K3, and this element is an element of the equivalence class of K1. So this means that K3 relates to K1, and because of K1 relates to K2 and the transitivity of the given relation, it follows that K3 relates to K2. So this means again that K3 is an element of the equivalence class of K2. So we showed that the equivalence class of K1 is a subset of the equivalence class of K2, because every element of the equivalence class of K1 is also in the equivalence class of K2. We can use the second statement that the equivalence class of K2 is a subset of the equivalence class of K1 just by repeating the steps, changing K1 with K2. But we can also use the transitivity of the relation, so not the transitivity, the symmetry of the relation, so that K1 relates to K2 also implies that K2 also relates to K1, and this means that you can change K1 and K2, so it follows that the equivalence class of K2 is a subset of the equivalence class of K1. B, two equivalence classes are equal or disjoint. So if the equivalence classes K1 and the equivalence class K2 have only one element K3 in common, then it follows from A that both the statement that the equivalence class of K3 is equal to the equivalence class of K1 because K3 relates to K1, as well as the equivalence class of K3 is equal to the equivalence class of K2 because K3 also relates to K2. So that means that if the equivalence classes K1 and K2 are not disjoint, then they are the same. Because each element of the set, of the given set, thus lies in exactly one equivalence class. So let's consider an example. The interest rate is 5% and we have two elements, 100 at the time of 0 and 105 at the time of 1. And those elements relate to each other because they can be written in the following equation. And we have another element, 1000 at the time of 2. This element is not in relation to the both elements because it can't be written in the following equation. You would have for t 47.19, which is not an integer and can thus be not an element of our given set.